unit from the module B, that is related to the time value of money. So kindly please do confirm the audio video quality at the earliest so that we could proceed. In this video, we will be covering some of the concepts related to the annuity, and further we will be solving the questions related to it. So do confirm the audio video quality at the earliest, and if you're new to our channel, please do subscribe the channel and press the bell notification icon so that you get updated whenever we upload the new video. The full course videos and all the previous lectures related to the BFM and ABM are available at our website iibf.info, and further you can enroll the courses right now and start preparing for the CAIIB 2022. So along with the chapter wise videos, you'll be getting the chapter wise previous year questions, case study videos, mock test, and complimentary access to the ePDF notes through our Android application. So do confirm the audio video quality at the earliest so that we could proceed. And if you want to join us on our WhatsApp group, you have to WhatsApp us writing CAIIB, mention your name along with it, and WhatsApp it to the number 83609444207. We will be adding you to the appropriate group. So the audio video quality over here seems to be working all fine. So let's start the session now. So annuity is all related to what? So let us take the case. Let us take the case related to the annuity first of all. That what is annuity? That what is annuity over here? That what is annuity over here? So in case of annuity, you're having a constant cash flow. There is a fixed cash flow, fixed amount of a cash flow over a fixed period. There is a fixed cash flow over a fixed period. So we can say that if you're having let us say that you are receiving rupees 1000 each and every month, or 1000 for each and every year for the next 5 years. For the next 5 years, in that case, it's what? It's basically an annuity. It is basically an annuity. So it is basically related to what? A constant cash flow over a fixed period of time. That is related to what? That is related to annuity over here. Okay. And further, it is a pre-fixed period and there is a fixed cash flow or constant cash flow over there. Okay. So if you are receiving or paying the amount in the beginning of the period, then it is said to be what? It is said to be annuity due. In that case, it is said to be annuity due. So if you are receiving the amount in the beginning of the period, in that case, it is said to be the annuity due. And further, if you are receiving or paying the amount in the end of the period, in that case, it is said to be ordinary annuity. In that case, it is said to be ordinary annuity. We already have covered these concepts under the JAIIB exams in accounting and finance for banking. So you must be aware of that. So if you are receiving the regular payments over the fixed tenor over there, in that case, it is related to annuity. So if you are receiving it in the beginning of the period, it is basically what? It is said to be the annuity due. And further, if you are receiving it in the end of the period or paying it in the end of the period, it is related to the ordinary annuity. Is that clear? Now, if I say that if you are paying the EMI, it would be example related to what? Kindly please do let me know at the earliest. If you are paying EMI, it would be example of the annuity itself. So what type of annuity it would be? It would be annuity due or ordinary annuity. In the case of EMI, that is the equated monthly installments, you are paying the EMIs to the bank now. In that case, it is basically what type of annuity? It is annuity due or ordinary annuity. It's the example of the ordinary annuity over there. It's the example of the ordinary annuity of the way, because you are paying the amount to the bank at the end of the interval itself. Okay. So if I say I'm receiving rupees 1000 for 5 years. So over here, I'll say the cash flow, that is C, is equal to what? C is equal to the cash flow. C is the cash flow, that is equal to rupees 1000 over here. And if I say that that the term is 5 years and I'm receiving it annually, in that case, N will be equal to what? N will be equal to 5 over here. N will be equal to 5 over here. And kindly please do let me know the C and N over here. Let us take the case that I have taken a loan of amounting rupees 10 lakh from the bank. I've taken an advance from the bank of rupees 10 lakh, and further it is to be paid in 10 years. It is to be paid in 10 years, and monthly installment of rupees 5000 is to be paid. I'm just assuming it. Let us take the case that the monthly amount of rupees 15,000 will be taking. That 15,000 rupees monthly installment is to be paid. In that case, what would be the C and what would be the N? What would be the value of C and what would be the value of N? Kindly please do let me know at the earliest. So in this particular case, what would be the value of C and what would be the value of the N over here? So kindly do answer at the earliest So if I have basically taken an advance from the bank amounting rupees 10 lakh over there, which is to be paid in the next 10 years in the form of monthly installment, and further we are basically paying an amount of rupees 15,000 rupees each month, in that case, what would be the value of N and what would be the value of C? So value of C, that is basically related to the cash flow. Now over here, if we are paying the amount rupees 15,000 each month, so 15,000 would be the C value. The C value would be 15,000, and if we are paying it over 10 years, in that case N would be equal to what? Because monthly installments are being paid now, so N will be equal to what? N will be equal to 12 into 10 years, that is equal to 120. So N over here will be equal to 120. Is that clear? So over here, Pineti Spurti has answered correctly at the earliest related to this particular question. So this is related to C would be equal to 15,000 and N is equal to 120 over here. And let us take the case that the interest rate of 12% was applicable. If the interest rate of 12% was applicable, what would be the monthly interest rate? If the interest rate of 12% is applicable, what would be the monthly interest rate? In the same example where I have taken an advance of rupees 10 lakh and it is to be paid in 10 long years, in 10 years monthly installments is paid. Let us say the case that the ROI is 12%, the monthly installment would be equal to 12 divided by 12%, that is equal to 1% itself. Is that clear? So now you are aware related to the concept of the annuity and further related to what is ordinary annuity and what is related to the annuity due over there. Now let me draw the ordinary annuity and annuity due over there so as to look at the annuities graphically. So as to look at the annuities graphically, that what is the difference between the annuity and the annuity due. Okay. So over here I am first of all drawing it related to ordinary annuity. So first of all we are going to cover related to ordinary annuity over there where the amount is to be paid or received in the end of the period itself. Is that clear? Now in this case particularly, if we say it is starting from 0, that it is showing the present time itself. So 0, 1, 2, 3, 4, 5. So I'm just drawing it for the 5 years. And let us take the case that we are receiving rupees 1,000 for each year. We are receiving rupees 1,000 for each year. What does it indicate? It indicates C is equal to rupees 1,000 over here, and for the N is given to be 5 over here. 5 over here, and the frequency is 5, that is related to that we are receiving the amount 5 years, and further we are receiving it for annually. Okay, now in this particular case, as we are receiving the amount at the end of the tenor itself, so it will be, the value will be received over here, so 1k over here, and further so on, the value will be received as such. Okay, now if the interest rate is applicable on this particular amount over there, let us take the case if I am investing rupees 1,000 at the end of the period itself. If I am investing the amount at the end of the period itself, at the end of the term itself, in that case, if I am investing rupees 1,000 at the end of 1 year, in that case there will be no interest for this particular time period. For this particular period, for first year, there will be no interest that is to be paid, and the interest will be paid for the this term, this one, and this one term. So for how many terms? For 1, 2, 3, and 4 terms the interest will be paid. And if we compare the same situation over here in the case of the annuity due, where the amount is being paid or being received at the in the beginning of the period itself, in that case if we draw the same timeline over here where it says 0, 1, 2, 3, 4 and 5. Okay, in this case particularly the amount will be invested here itself. It will be invested here itself, and further it will be invested here 1, 2, 3, 4 and 5, and 1, 4 and 5 over here. Is that clear? In the beginning of the period itself, the amount is invested. Now this amount will be receiving the interest for this particular period 1, 2, 3, 4 and 5 itself. So in the case of the ordinary annuity, the interest was over there for 4 terms, whereas in the case of the annuity due, the interest was there for 5 terms. We are taking the case where we are depositing the amount. Is that clear? Is that clear? So that is related to what? That is a graphical difference between the ordinary annuity and the annuity due. You must understand that. Now let us understand the concept related to the present value and the future value. Let us understand the concept related to the present value and the future value. First of all, we'll be considering the concept related to present value. Now the present value, what it is, does it indicate? I already told you that the money tomorrow or money in future is not equal to the money in our hand right now, and we can discount it, and the rate at which it is discounted is said to be what? It is said to be the discounting rate itself. Okay, so the same case is over here. I'm receiving it for 3 years. Let us take the case I'm receiving rupees 1k for 3 years. I'm not basically saying whether it is related to annuity due or ordinary annuity. I'm simply saying that I'm investing rupees 1000 for 3 years over here. So this is basically related to the present value over here, and this is the first year, second year, and third year. Now if you want to get the present value of the annuity, if you want to get the present value of the annuity, we'll be calculating the present value of all the cash inflows. We'll be calculating the present value of all the cash inflows over there. So that will be basically related to what? That is related to the present value of the annuity. So that will be related to that what is the worth of that particular cash flows that I'm going to receive in the annuity itself. That is related to present value of the annuity. Okay, and when I say what will be the future value of the annuity, let me give an example that you are basically depositing an amount of rupees 1000 each year, so each month for 2 years. Okay, so you're basically having a recurring deposit with you, and you're depositing rupees 1000 for each month for next 2 years. In that case, you're basically wondering that what amount you will be receiving, what would be the maturity that will be receiving at the end of the 2 years itself. That is basically related to what? That is related to the future value. So the future value is appreciated because that is invested on some interest, and further the present value is discounted on some interest rate. The present value is discounted on the interest rate. So that is basically the present value and the future value. We have already learned the concept related to it. Okay. So now let me tell you the formulas related to the different formulas for the ordinary annuity and the annuity due first of all. So you need to remember only and only one formula, and further from one formula itself you can form the other formulas too. So you need to remember one formula only, and you can remember 4 other formulas from the same. Okay. So first of all, we are considering it related to the present value of the ordinary annuity. Present value of the or we can say the future value of the ordinary annuity. The future value of the ordinary annuity. So what is the formula related to it? So it is equal to the C, that is the cash flow, and for the 1 plus I raised to power n minus 1 divided by I. So that is the formula related to the future value of the ordinary annuity. That is related to the future value of the ordinary annuity. I'm representing interest over here by term I over here. What does it indicate? It indicates that interest will be paid. Okay. And further, the present value of the ordinary annuity, the formula is quite same. That is the same. That is C. And for instead of I, I'll be using the term R over here. Otherwise, in formula it is all same. Okay. That is for reference only, because R over here is the discount rate, where I over here is the interest rate that is being paid to you, and R is the discount rate at which you will be discounting the future cash flow to the present value itself. Okay. And further it will be R, and only one different and one extra term is over there in the denominator itself. That is 1 plus R raised to power n, and that would be related to present value of ordinary annuity. This is quite simple now. So as to remember the formulas over here, you just need to remember this particular formula. You just need to remember this particular formula, and from this particular formula you can form the other formulas itself. Okay. So this one was related to future value of ordinary annuity, and this is equal to cash flow, and further multiplied by 1 plus I raised to power n minus 1 divided by I itself. And further for the present value of ordinary annuity, the same formula would be there, only this term itself in the denominator that we added up over here. That is 1 plus R raised to power n. That would be the term that would be added over here. That is related to the present value of the ordinary annuity in this case. Okay. Further related to the future value of annuity due. Future value of annuity due. Now I just told you that in case of future value of annuity due, that was basically deposited over there for the one extra period, for one extra term over there. That is the thing that you need to remember. So replicated from the same formula itself, you'll be writing it same. That is C, and for the 1 plus I raised to power n minus 1 divided by I itself, and you'll be just multiplying it with 1 plus I. That is for the one extra term. You can memorize it in that manner. So it will be multiplied by 1 plus I. That is the formula related to future value of the annuity due. That is related to future value of annuity due. And further, if we want to remember the formula related to present value of annuity due, that is equal to what? That is equal to the same formula goes over here. That is C 1 plus R, because there will be a discount rate raised to power n minus 1 divided by R. And further, because this is for what? This is for the annuity due itself. So there is a another term. So we'll be writing 1 plus I R over here again. And further in the denominator itself, it will be the extra term that we added in the present value formula. That is 1 plus R raised to power n. This is how you can memorize all these formulas over here. I told you that remembering one formula and you can retain 5 formulas. Which one is that 5th formula? Let us have a look at it. That is related to EMI. That is related to EMI. Any lame guesses that what formula would be related to the EMI itself? any lame guesses, because you just answered me one question related to, when I asked that this is related to the present value, and further you just told me that EMI that is related to this particular formula. Can anybody have a idea related to EMI would be related to the first formula or the second over third over fourth? If not any, there is not an issue. Let me tell you clearly that present value ordinary annuity formula is basically the formula from where we can also calculate the EMI itself. Okay. So this is a formula related to EMI. Over here, C is the EMI that you want to calculate. Present value of the ordinary annuity is basically related to what? That is related to the loan amount. So whatever amount that is sanctioned, that is basically the loan amount. That is sanctioned the loan amount. So just take it as that manner. Let us take the case that amount of rupees 10 lakh has been sanctioned to a person at 10% rate. And further this is for sanction for a period of 5 years. Now in this particular case, the 10 lakh rupees is basically related to what? This is the present value of the loan amount so sanctioned. And for the EMI of the amount is to be paid. Okay, that is basically the present value of the ordinary annuity formula is related to the EMI, from where we can do calculate the EMI, and I'll be telling you that how you can do calculate the different annuities over there, and for the what the thinking process related to it. Is that clear? Is that particular part clear over here? So that is related to what? That is related to annuity. Annuities are of two types: ordinary annuity and annuity due. And further we covered the present value and future values of these different annuities over there. Now we will be solving the questions related to that. Okay. So over here we are having some of the questions, and then we'll be learning the concepts related to the sinking funds over there, the annuities, growing annuities, perpetuity, console modes, each and everything that we'll be covering. So first of all, we have to concentrate on the questions over here. First question, it says simple rate of interest or flat rate of interest. Simple rate of interest or flat rate of interest is the amount which is paid every year as what of the amount borrowed. Fixed percentage, varying percentage, fluctuating percentage, or percentage as per discretion of the lender. So kindly please do answer at the earliest. What would be the right answer in this particular case? Simple rate of interest or a flat rate of interest is amount which is paid every year at fixed rate of interest. This was quite easier question over here. So fixed interest rate is being paid. So option A over here is the right answer. And further, Priyanka Tejawat has answered the question at the earliest. So option A over here is the right answer. Next question, it is related to the compound interest equation. That is A is equal to P into E raised to power RT. That is for your information sake, because such type of questions can also be asked in the statement type questions over there. So compound interest rate equation, that is A is equal to P into E raised to power RT, is applicable in case of continuous compounding. It is applicable in case of continuous compounding. Again, Priyanka Tejawat has answered correctly over here. So option A over here is again the correct one. So option A is the right answer. Let me mark that. Further, let's move to the third question. Okay, now you need to solve this particular question. X borrowed rupees 10,000 from the bank at 12% per annum for 1 year. Payable on equated monthly installment basis. So it is to be paid on monthly basis. And further, what is the amount of EMI? And we need to calculate the amount of EMI. Okay, I already told you that the present value of our ordinary annuity formula is related to that. So you must be remembering that formula first of all. We need to write the future value formula, that was 1 plus I. Instead of I, will be writing R over here. So R raised to power n minus 1 divided by R over here. And further, it was 1 plus R because it is related to present value. So it is 1 plus R raised to power n. Now over here, you need to mention the different values first of all, and then you must be starting with the calculation part. Okay. So what would be the value of C? What would be the value of R? And what would be the value of N? Kindly do mention these values at the earliest so that we will be proceeding with the calculations. So what would be the value of these variables? You need to understand what would be the value. So over here, the amount borrowed is rupees 10,000. So it is not C over here. C is that actually we need to calculate. C is actually what? It is what we need to calculate. It is basically related to what? It is related to EMI that we need to calculate. Okay. And further, 10,000 over here is related to what? It is related to present value that is already given to you. So it is basically 10,000 amount that is a present value that is given to you. And if we basically look at the R value, that is a rate of interest, that is 12% per annum for 1 year. That is for 1 year, but you are calculating it for monthly purpose na. So over R over here would be equal to what? R will be equal to 1%. And what would be n equal to? N will be equal to 12 over here, because there are 12 months in 1 year, so it will be equal to 12. Now you need to just implement these values over here and you can calculate it. So we are just replacing the values over here, and we need to see, we'll be writing as EMI that we need to calculate, and for the 1 plus R is 1% over here, converting it to a decimal part, that is 0.01. So 1 plus 0.01 is equal to 1.01 raised to power 12, and further minus 1 divided by 0.01, and further 1.01 raised to power 12. This is that you need to calculate. This is that we need to calculate, and using the simple calculator you can easily do calculate this, and this is quite possible over there so as to calculate. So I'm just telling you the way out that how we can do calculate 1.01 raised to power 12 first of all. So whenever we need to calculate 1.01 raised to power 12, it is not like that you will be writing again and again, multiplying again and again. There is a simple thing that you need to follow, that is 1.01 first of all, multiply sign, again 1.01. Now look at the raised to power. Over here raised to power is 12, and further you need to press the equal to sign 12 minus 1 times over here. So let us take the case if it is a raised to power n, and further I need to calculate a raised to power n. What would be the procedure I'll be following in the simple calculator? I'll be writing a, then multiplying by a, and further will be typing the equal to sign n minus 1 times. Okay, same procedure I'm following over here. I just wrote 1.01 multiplied by 1.01, and raised to power over here is 12. I'll be pressing equal to sign 11 times. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is a value related to 1.01 raised to power 12 over here. That is 1.1268. I'm just mentioning it over here. So it is 1.1268. Is that clear? So it is 1.1268 minus 1 divided by 1.1268 divided by 0.01. So that is the answer related to it. So it is 11.255. So the right side we are having the term, I'm just writing it over here. So it is 10,000 is equal to EMI multiplied by 11.2553. So it will be 10,000 divided by 11.2553, and here comes the answer, that is 888.47. So the EMI over here, it comes out to be 888.47. that is the answer related to this question. That is option A over here. And first of all, let me tell you, Rakesh Sharma has answered correctly over here. That is option A is the right answer. Very right, very right. That is option A over here. Is that clear? That, and how easier it was so as to memorize the EMI formula. Okay, so you just need to remember one formula, and you can definitely can get the answer to the another formulas too. Okay, now we'll be looking at the different factors that how we can solve the other questions too. So let's solve the another problem. So we will be covering it in another question, so do not worry about it. If you have not understood it well in this question itself, we will be solving it in another question itself. So A opened a recurring deposit account. So A opened a recurring deposit account with the bank to deposit rupees 16,000 by the end of each year. Now the amount is to be deposited. Now just concentrate, focus on the words. It is to be deposited at the end of each year. So it is related to what? It is related to ordinary annuity. First of all, we get to know. And further, at 10% interest rate, how much he would get at the end of third year. How much he would be getting at the end of a third year. Okay. So now let me tell you over here, amount being deposited each year is equal to 16,000. So over here, clearly it is given that C is given to be 16,000. And further, amount is being deposited yearly. And further, we need to calculate the amount which would be there after the end of a third year. So N over here will be equal to 3. And R is given equal to what? R is given to be 10% over here. That is the interest rate is given to be 10% over here. And further, we will be calculating the future value or present value. Kindly do answer at the earliest. We will be calculating the future value or the present value. I want you all to participate, and I want you all to answer so as to get the idea related that where we'll be using the future value formula, where we'll be using the present value formula. We'll be using the future value formula over here, because just draw it on the timeline. Okay, so we are basically depositing rupees 16,000 each year at the end of the term, and we need to get the value at the end of the third term. What value we will be receiving over here? what value we'll be receiving over here, that we need to calculate. Now, and for that purpose we are basically going forward to the future. We are basically not calculating the present value of these cash flow, we are going to calculate the future value of these cash flow. So this is the future value we need to calculate over here. So Snehangsu has answered correctly first of all over here that the future value is to be calculated, and it is clearly mentioned that the amount is being deposited at the end of the period, so it will be the future value of the ordinary annuity. So what is the formula related to it? So future value of the ordinary annuity formula is quite simple. I just told you that this is the first formula, that is 1 plus I raised to power n minus 1 divided by I over here. This is the simple one that you need to calculate, and C over here is given to be 16,000, and for the 1 plus I is equal to 10%, so it will be 1.1 raised to power 3 minus 1 divided by 0.1 over here, and that is that you need to calculate. That is what you need to calculate. Okay, so over here I'm just solving it for you. So 1.1 multiplied by 1.1 multiplied by 1.1 again, so it is 1.331 minus 1 divided by 0.1 and multiplied by 16,000 again. So this is the value related to it, that is 52960. 52960 is the right answer over here. So the answer over here is 52960, that is option D over here is the right answer. 52960, if I'm not wrong, 52960 comes out to be the right answer. Yes, option D is the right answer over here. And do not make any of the calculation mistakes, because even if we are knowing the concept and we are doing it wrong, that would be basically give us 0 marks. Okay, so option D over here is the right answer. Do not worry about the concepts. We'll be covering a whole lot of the numericals over here, and that would be quite easier for you to continue. So repayment of housing loan installment for a predetermined period of EMI basis is an example of what? Single cash flow, annuity, perpetuity, or any of the above. So repayment of house loan installment for a predetermined period of on EMI basis is an example of what? Question number 5 is quite simple. It is single cash flow, or it is annuity, or perpetuity, or any of the above. Single cash flow is what actually where only and only one flow is there. Either you are basically paying the amount or receiving the amount. That is basically to do single cash flow. And what do you mean by annuity? Where there is a series of payment, or you're receiving a series of the payments over there that over a fixed period of time at regular intervals. That is related to what? That is related to annuity. So in case of housing loan EMI also, you're paying the fixed amount now over the tenor over there. That is basically the example of annuity over there. So option B is the right answer. Definitely option B is the right answer over here. So almost all of you have answered correctly over here. That is option B is the right answer, and Priyanka Tejawat has answered the question at the earliest. That is option B. And now what is this perpetuity? What is this perpetuity related to? Perpetuity is actually related to when you are receiving the amount for a lifetime period. Let me give an example. Let us take the case of a pension itself. So if you are receiving a lifetime pension, it is basically related to what? It is a perpetuity that you are receiving. It is a perpetuity you are receiving, and if the question is there that you need to calculate the present value of the perpetuity. So perpetuity is basically you are receiving the value for a continuous period, that there is no limitation, there is for indefinite period. It is for indefinite period. That is said to be perpetuity. And if the question comes, what is the present value of the perpetuity? What would be the answer? So what is the present value of the perpetuity? Kindly please do let me know the answer at the earliest. So present value of the perpetuity is quite simple. It is A divided by R. The present value of the perpetuity is equal to A divided by R. It is quite simple. You just need to remember it is A divided by R, and that is it. You know the concept, you know the formula. That is it. That is what is going to be asked in the question itself. Okay. Further, also it may be the case that there is a growing perpetuity. Now, what do you mean by growing perpetuity? That you are receiving the amount. For an indefinite period, that there is no time limit related to it, but also the amount that you are receiving, it is growing at some particular rate. It is also growing at some particular rate. So let us take the case that today it is A, and tomorrow it is A plus B, then it is A plus 2B. So it is growing at a constant rate. We are saying it is growing at what? It is growing at a constant rate. In that case, what would be the formula related to it? If you have not idea related to it, let me tell you that the formula in that case, it is equal to C divided by R minus G. C divided by R minus G, where G is the growth rate and R is the discount rate. Where R is the discount rate and G is the growth rate over there. Is that clear? So in that case, it is equal to C divided by R minus G. Only that thing that you need to remember over here. Now let's move to the next question. It says, X wants to receive rupees 40,000 per annum for 20 years by investing at 5%. X wants to receive rupees 40,000 per annum for 20 years by investing at 5%. How much will he has to invest now? Now there are a few things that you need to remember related to the questions whenever such questions comes. Then when you need to resolve, what are those issues? First of all, if the question is silent about that the amount was being deposited at the end of the period or in the beginning of the period, if the question is silent about it, we will also be using the formula related to the ordinary annuity. We will also be always be using the formula related to the ordinary annuity over there. And also now let us take the case over there which is mentioned in the question itself, that X wants to receive 40,000 rupees per month, and we want to know that what amount we will be investing in right now. That what amount we have to invest right now. That is related to what? That is related to the present value. That the present value that we will be investing, and we will be having the cash flows of rupees 40,000 per annum for the next 20 years at 5% per annum. That is what is asked over there. And what we need to calculate? We need to calculate the present value. Question is silent about it. It is not the amount is being deposited in the beginning of the period or in the end of the period. We'll be considering what? We'll be considering it on the case of the ordinary annuity itself. So we'll be calculating the present value of the ordinary annuity. That is to be calculated over there. And what is the formula? You must be remembering the formula by now. It is 1 plus C into 1 plus R raised to power n minus 1 divided by R multiplied by 1 plus R raised to power n. This is the formula that you need to solve, and we will be calculating over there. We need to calculate the present value. C over here is 40,000, that the amount that we need to receive, and the amount is being invested at 5%. Now we will not be converting into the monthly rate because the amount is to be received on yearly basis. So it will be 1.05 raised to power 20 because n is 20 over here, minus 1 divided by 0.05 multiplied by 1.05 raised to power 20, and further this is the value over here. Now how to solve 1.05 raised to power 20? Now it could be quite hectic and quite confusing too if you will be pressing the equal to sign for the 19 times. As I already told you, what is the method? First of all, you do write 1.05 on calculator, then multiply sign, then 1.05 again. Second step, it would be pressing the equal to sign for n minus 1 time. Now over here n is equal to 20, so it will be that you will be pressing the equal to sign for 19 times, but it's quite hectic and also quite confusing itself. Okay, so what we'll be doing, we'll be making factors of this 20 itself over here. Now mathematically 1.05 raised to power 20, it is equal to 1.05 raised to power 4 and further raised to power 5. Mathematically these are equivalent. So we'll be, first of all, we'll be solving out 1.05 raised to power 4, and that we can do easily. That is 1.05 raised to power 4, and that is 1.05 multiplied by 1.05. Now press the sign equal to sign for 3 times, so it will be 1 2 3. So it will be 1 2 3, so it comes out to be 1.2155 raised to power 5 that you need to calculate. So it will be multiply sign again and for the 1.2155. Now it is raised to power 5 and we'll be pressing the equal to sign for 4 times, so it will be 1 2 3 4. So this is the answer related to this particular term. That is we can write over here, that is 1.05 raised to power 20. It is equivalent to 2.653. So we'll be solving it. So it will be 2.653 minus 1 divided by 2.653 divided by 0.05 and further multiplied by 40,000, and that would be the answer. So it is, the answer comes out to be 498,540. So answer comes out to be 498,540. 540 is the answer over here. So option A over here is the correct answer over here, because there must be some decimal parts over there that we missed over there. So that is why the difference is there, and for the right answer over here is option A. In this particular case, the question 6, option A is the right answer. So Anita Prajapati has answered correctly at the earliest. That is option A is the right answer. Option A is the right answer. Is that clear? Now let's move to the next question. Question number 7. It says Z borrowed rupees 65600 for 2 years at 5% per annum and to be returned in 2 equal annual installments. And these are to be returned in 2 equal annual installments. What will be the value of the installment? It's quite easier. It's quite easier. Again, the EMI formula, that is a present value of ordinary annuity formula. So I'm writing the values directly over here. So present value of the loan that is given to be 65600. And for the EMI that we need to calculate, that the C, that is the cash flow that we need to calculate, and 1 plus R over here because it's annual installment. So it is 1 plus R. It is given to be 5% over here. It's 5% now. So it will be 1.05 raised to power 2 years. So raised to power 2 minus 1 divided by 0.05 and multiplied by 1.05 raised to power 2. This is that you need to solve, and for that will be the formula related to it. This is quite easier. I think that you can calculate it easily. You can calculate it easily. Let me calculate it for you. So it will be 1.05 multiplied by 1.05 again, and that is equal to 1.1025 minus 1 divided by 1.1025 divided by 0.05. It comes out to be 1.8594. It comes out to be 1.8594. I'm writing it over here. This value is reduced to 1.85941, and further 65600 divided by 1.85941, and the answer comes out to be 35280. And the answer comes out to be 35280. So option A over here is the right answer. And Anita Prajapati has answered the question at the earliest. So option A is the right answer in this particular case. Is that all clear? Now you must be aware that where we are using what formulas and how we can solve it easily using the simple calculator. If you're liking the video, can please do hit the like button. There are 90 persons online and 28 likes only. Okay. The rule of 72 determine the number of years during which an amount remains what at a given rate of interest. What would be the answer related to question number 7 in this particular case? What would be the answer related to question number 7 in this particular case? It is double. Okay, so it is basically related to option A over here. So option A is the right answer. So over here, question number 8, option A is the right answer, and Anita Prajapati has answered the question at the earliest. Option A is the right answer. And now let us understand the concept related to sinking fund through an example. Let us take the case that person A wants to purchase a car after 7 years. He wants to purchase a car after 7 years, amounting rupees 10 lakh. Amounting rupees 10 lakh. And let us take the case that opportunity is available that he can do invest the amount at 7% right now. He can do invest the amount at 7% right now. What amount he needs to deposit, he needs to set aside so as to have a total amount of 10 lakh rupees after 7 years. So what amount he needs to deposit annually at 7% that he'll be receiving rupees 10 lakh at the end of 7 years, so as to buy the car, so as to buy his dream car over there. So that is basically related to what? That is related to the sinking fund over there, where we do put our money at a particular rate of interest over there, and we are basically investing it again and again over a fixed period of time. So it is also forming what? It is also forming an annuity. Okay, but it is said to be sinking fund because we are having a goal amount that we need to have in the future itself. So that is related to what? That is related to sinking fund itself. Now how we will be solving this question? What formula we will be receiving? What formula, not receiving actually, what formula we will be using over here? What formula we will be using in this particular case? Now the question is silent about that the amount is being deposited in the beginning of the year or at the end of the period. So it will be what? We'll be using what formula? We'll be using the ordinary annuity formula. We will be using the ordinary annuity formula. What formula we'll be using? We will be using the present value formula or future value formula? We will be using the present value formula or the future value formula. Kindly please do answer at the earliest. It will be the future value formula because we need to calculate We are basically already having the 10 lakh value now, and we need to calculate the cash flow over there. We are already having the future value over here, and we need to calculate the cash flow that is to be deposited each and every year. So we will be using the future value formula over here. We will be using the future value formula over here. And what is the formula? It is C into 1 plus I raised to power n minus 1 divided by, that is the formula that you need to use. And the future value you are already provided with, it is 10 lakh rupees. The future value you are already provided with, that is 10 lakh rupees. C is the value that you need to calculate. I is given to be 7%, so it is 1.07, and this is for 7 years, so raised to power 7 minus 1 divided by 0.07, and that is the value that you need to calculate over here. So let me solve it for you at the earliest. So it is 1.07 multiplied by 1.07. Now raised to power is 7, so we'll be pressing equal to sign for 6 times. So it will be 1, 2, 3, 4, 5, 6. So it comes out to be 1.606. 1.606 minus 1 divided by 1. Sorry, I just made some mistake. So 1.07 multiplied by 1.07, and it comes out to be 8.65. It comes out to be, this value is reduced to 8.654, and it will be 10 lakh divided by 8.654, and the answer comes out to be, C comes out to be actually 11,553. 11,553. So A is to deposit 1,15,553 rupees each year, so as to get rupees 10 lakh at the end of 7 years if the amount is being deposited at 7% each year. Okay, so that is basically related to what? That is related to the sinking fund over here. I hope that you must have understood the concept related to the sinking fund also. So that is related to what? That is related to the sinking fund formula over there. Okay. And what do you mean by the balloon repayment loan? What do you mean by the balloon repayment loan? So in the case of the balloon repayment loan, over the tenor of the loan, only and only the interest amount is being paid. Only and only the interest amount is being paid. Let us take the case that the amount of rupees 1 crore was basically 1 crore was advanced, and further the interest of 10 lakh rupees each and every year was being paid by the firm itself. It was advanced for the 10 years. It was advanced for the 10 years. Now each and every year the firm paid rupees 10 lakh rupees as basically interest. As at interest, 10 lakh rupees were paid each and every year, and at the end of the 10 year, at the end of the tenor of 10 years, the amount of rupees 1 crore was paid in one shot. It was paid in one hit over there, and further that is said to be what? That is said to be the balloon repayment loan. Now what would be the appropriate example related to it? The bonds and debentures. The bonds and the debentures are appropriate example to it, where a company is issuing a bond. Let us take the example where the company XYZ issued a bond, and further these bonds were issued. Let us say the case that face value of the bond is rupees 100 over there, and company basically has a liability so as to pay coupon of 8% each and every year. 8% coupon is to be paid by the company each and every year. Now the company will be paying 8%. Now the company will be paying the 8% interest each and every year, and after the maturity, let us take the case the maturity is after 3 years. After the maturity, that is after 3 years, the company will be paying 100 rupees to the bond owner itself. That is related to what? That is related to the balloon repayment loan. That is related to the balloon repayment loan. Is that clear? Is that part clear over here? And further, if you are having a growing annuity, previously we basically considered the example related to growing perpetuity, and we basically learned related to growing perpetuity, and the formula was related to, in case of growing perpetuity, if you remember, the formula was related to A divided by R minus G was the formula. A divided by R minus G was the formula over here. And further, if we need to calculate the growing annuity, I'm not talking about the perpetuity, I'm talking about growing annuity, where the fixed term is there, where there is fixed term, that is basically said to be what? That is said to be the growing annuity. Okay, now in that particular case the formula is quite different. In that case the formula is quite different, and it is equal to what? It is equal to A into 1 plus A is equal to 1 plus that is equal to 1 plus G, that is a growth rate, and further divided by R minus G, and further it is equal to 1 minus 1 plus G raised to power n divided by 1 plus R raised to power n. So that is a formula related to the growing annuity. That is a formula related to the growing annuity over here. Okay, where R is the discount rate, G is the growth rate over here, and further A is the amount that is being received. Okay, and that is growing actually. Okay, so over here this is the formula that you need to use, and is the tenor over here, and this is the formula that by which we can do calculate the present value of the growing annuity, by which we can do calculate the present value of the growing annuity over here. Okay, is that particular part clear over here? So it is equal to A into 1 plus G over R minus G, 1 plus G over R minus G multiplied by 1 minus 1 plus G raised to power n divided by 1 plus R raised to power n. That is the formula related to it. That is the formula related to it. And further, where the R is equal to G, where R becomes equal to G, if the R becomes equal to G, that the discount rate becomes equal to the growth rate, in that case the present value is reduced to n into A. It is reduced to n into A. We need not to resolve the questions based upon it, because never the case it is that the questions are being asked based upon this. The questions are generally asked for the present value and the further the future value of the annuities itself. Okay, you just need to memorize this formulas over here, because the questions related to theoretical parts are also being asked in the CAIIB itself. It's not the case that you are being asked only and only the numerical part. Okay, so that would be related to the growing annuity. Now what is the case of the console bond? Now what do you mean by console bond? What do you mean by the console bond? What is console bond? Console bond is that bond which is having no maturity, which is having the, or we can say perpetual bond. Perpetual bond or console bond, each and everything is the same. So console bond means no maturity. You will be paid the coupon rate over the periods. You will be paid the coupon rate interest over the periods. That is equal to, there is no maturity. And what is the present value formula for the console bond? What is the present value formula for the console bond? It is equal to A divided by R. That is a present value formula. That is a present value formula for the console bond itself. Okay, so if we say that you are being receiving that the face value is rupees 1000. If we say the face value is given to be rupees 1000, the face value of the bond is given to be rupees 1000 over here, and further it is mentioned that the coupon rate is 10%. The coupon rate is given to be 10% over here. In that case, what would be the present value of the bond? What would be the present value of the bond? Kindly please do answer at the earliest. In that case, if the face value is given to be rupees 1000 and further the coupon rate is 10% over here, in that case, what would be the present value of the bond? If we need to calculate the present value of the bond, it will be equal to what? It will be equal to A divided by R. Now over here, A is equal to what? A is equal to what? A is equal to the coupon that you are receiving. A is equal to the coupon you are receiving, isn't it? It is a coupon that you are receiving, that is equal to 10% of 1000 is equal to 100 over here, and further R over here is equal to what? If the interest rate we say in the market, it is 8%. I actually haven't mentioned the interest rate over here in the market. Let us say the case that the interest rate in the market, that is a discount rate we need to consider. If it is given to be 8%, if it is given to be 8% in the market, it will be equal to what? It will be 0.08 over here, and this is how we can calculate the present value of the console bond. This will be equal to present value of the console bond, that is equal to 100 divided by 0.08, that is equal to 1250. That will be equal to the present value of the console bond in this particular case. Okay, So we were provided with the future value, coupon rate was given to be 10%, the market interest rate, or we can say the discount rate is given to be 8% over here, and we need to calculate the present bond, present value of the console bond, that will be equal to A divided by R, that is equal to 100 divided by 0.08 over here, 0.08 over here. So definitely it will, actually I just made a mistake over here related to calculation. So it will be 12, so it will be equal to 100 divided by 0.08, not 8 over here. Yes, definitely it is right, not no calculation mistake over here. So it is 1250 over here, not 12500. It is 1250 over here. Okay. Let's further see if the question is there. Let's solve a question based upon this. So Z raised a housing loan amounting rupees 10 lakh at 12% rate of interest, repayable in 10 years. We need to calculate the EMI for the same. We need to calculate the EMI for the same. The same formula is to be used, where we are provided with the loan amount, that is 10 lakh rupees, and for the EMI that we need to calculate, and over here it is 1 plus R raised to power n minus 1 divided by R into 1 plus R raised to power n. So what would be the value of R and what would be the value of n? What would be the value of R and what would be the value of n over here? What would be the value of R and what would be the value of n over here? R over here will be equal to, because rate of interest is given to be 12%, but we will be calculating the monthly rate of interest. It is given to be per annum. We will be calculating monthly rate of interest, so it will be 12% divided by 12 per month over here, that is equal to 1%. Decimal, it will be equal to 0.01, and n is equal to, basically we need to calculate for 10 years now. For so 10 into 12, that is equal to 120. Okay, so it will be 120 over here. That is what we need to calculate and solve over here. Okay, so first of all it will be 1.01 raised to power 120 that you need to solve, minus 1 divided by 0.01 for the 1.01 raised to power 120 that you need to solve. This is the actually main calculation part over here that we need to solve over here. So first of all we will be solving 1.01 raised to power 120 and we'll be forming the factors over here. So it will be 1.01 raised to power 10 raised to power 12 over here. That is how you can easily solve the 1.01 raised to power 120. So first of all we will be solving 1.01 raised to power 10, so that is equal to 1.01 multiplied by 1.01, and raised to power 10 means you will be pressing equal to sign for 9 times. So it will be 1 2 3 4 5 6 7 8 9. I just made some mistake, there was some slippage. So 1.01 into 1.01, it is 1.1046. So it is 1.10462 raised to power 12 that you need to solve. Multiplying it again, 1.10462, and for the raised to power 12 means equal to sign 11 times. So 1 2 3 4 5 6 7 8 9 10 11. So it is equal to 3.3. So 1.01 raised to power 120, it comes out to be 3.003. So minus 1 divided by 0.01 divided by 3.3003, that is equal to 69.72. 69. So this whole value reduces to 69.702, and further it will be 10 lakh divided by 69.702, and that would be the answer related to it. That is 14346. 14346. So EMI over here it comes out to be 14346. So option C over here would be the right answer. Option C in this particular case is the right answer. Now let's move to the next question. It says, when a fund is created to meet the need of a specified amount in future, and it is accumulated by means of equal periodic deposits, it is called which fund? Mutual fund, sinking fund, accumulated fund, or any of the above? Which one of the following would be the right answer? When a fund is created to meet the need of a specified amount in the future, it is basically what? And it is accumulated by means of equal periodic deposits. It's called what? It's called the sinking fund. It's called the sinking fund. It's called the sinking fund over there. Option B is the right answer in this case. And that would be all related to today video. So last question, that is question number 10. Right answer has first of all been given by Rahul Singh Rajput. So question number 10 is the right answer. Right answer is option B, that is a sinking fund. So kindly please do rate the session at the earliest. And further, if you want to join us, do enroll visiting our website iibf.info, or you can download our Android application from the Google Play Store. So do visit right now and start enrolling into the course and start preparing for the course itself. You will be getting the full course videos, chapter-wise previous questions, case study videos, mock test, and complimentary access to the ePDF notes through our Android application. Do rate the session, and further, if you want to join us on our WhatsApp group, you have to WhatsApp on our number mentioned over here, that is 836094427. Writing CAIIB, mention your name along with it, and WhatsApp it to the number, and we'll be adding you to the appropriate group over there. So that would be all related to this session. Thank you so much, and see you again tomorrow at the same time, 8:15 p.m. in the evening. BFM case studies will be uploaded for the premium members only. Those will be available for the premium members only. Okay.